Hello all, my name is Vaishnav KP. Today we will discuss the topic on algorithm design. Introduction to algorithm design. The word algorithm means a set of finite rules or instructions to be followed in calculations or other problem solving operations or a procedure for solving a mathematical problem in a finite number of steps that frequently involves recursive operation. In the figure, set of rules to obtain the expected output from the given input. This figure shows what exactly an algorithm means. What is the need for an algorithm? The algorithms are necessary for solving complex problems efficiently and effectively. They help to automate processes and make them more reliable, faster and easier to perform. Algorithms also enable computer to perform tasks would be difficult or impossible for human to do manually. They are used in various fields such as mathematics, computer science, and analyze data and provide solution to problems. There are six important characteristics of algorithm. First one is well-defined input. Second one is clear and unambiguous, language independent, well-defined output, finiteness, and feasible. Let's explain what is well-defined input. If an algorithm says to take input, it should be well-defined input. It may or may not take input. Clear and unambiguous. The algorithm should be clear and unambiguous. That is, each of the steps should be clear in all aspects and must lead to only one meaning. Third one is language independent. The algorithm must be language independent. That is, it must just have plain instructions that can be implemented in any language and yet the output will be the same as we expected. Well defined output. The algorithm must be clearly defined what output will be yielded and it should be well defined as well as it should produce at least one output. Finiteness. The algorithm must be finite. That is, the algorithm should terminate after a finite number of time. Last one is feasible. The algorithm must be simple, generic and practical such that it can be executed with available resources. So, these six are the important characteristics of developing algorithms. Next is steps in developing algorithms. There are five important steps in developing algorithm. We can discuss each of the step. First one is obtain the description of the problem. Clearly define the problem you are trying to solve. Understand the requirements, constraints, and goal. This step involves identifying the input and the expected output, understanding the problem context and constraint, specifying performance criteria that is speed, memory usage. We can take an example that is there are following discussion. The word client refer to someone who want to find a solution to a problem, and the word developer refer to someone who find a way to solve the problem. Developer must create an algorithm that will solve the problem. The client is responsible for creating a description of the problem, but this is often the weakest part of the process. It is quite common for a problem description to suffer from many of the condition, that is The description relies on unstated assumption. The description is ambiguous. That are the main reasons. Next step is analyze the problem. We analyze the problem type. Develop a high level strategy to tackle the problem. This may involve breaking down the problem into smaller, manageable subproblem. Choosing the type of algorithm, that is greedy, divide and conquer, dynamic programming. Considering different approaches and selecting the most suitable one. The purpose of this step is to determine both the starting point and ending point for solving problem. A good problem description make it easier to perform this step. When determining starting point, we should start seeking answer to the questions, that is, what data are available, where is that data, what formulas pertain to the problem, what rules exist for working with the data. When we determining endpoint, we need to describe the characteristics of a solution. Asking to the questions that what new fact will we have, what item will have changed, what changes will have been made to those items. These questions may arise. Third one is develop a high level algorithm. Create a detailed plan or pseudocode for the algorithm. This step involves defining the step-by-step procedure to solve the problem, writing the pseudocode or flowchart to visualize the process, ensuring all edge cases and error conditions are handled. An algorithm is a plan for solving a problem, but plan comes in several levels of details. It is usually better to start with high level algorithm that include major part of a solution. Fourth step is refine the algorithm by adding more details. Review the result from the initial testing phase. Identify areas where the algorithm's performance, readability, or maintainability can be improved. Make adjustments to the algorithm based on feedback and testing outcome. Retest the refined algorithm to ensure that changes have not introduced new issues. A high level algorithm shows the major steps that need to be followed to solve the problem. We need to add details to this step, but how much details should we add? Unfortunately, the answer to this question depends on the situation. We have to consider who is going to implement the algorithm and how much that person already know how to do. When our goal is to develop algorithm that will lead to computer programs, we need to consider the capabilities of the computer and provide enough details so that someone else could use our algorithm to write a program that follows the step in our algorithm. And there is a stepwise refinement. That is, stepwise refinement means it is the process of developing a detailed algorithm by gradually adding detail to a high level algorithm. The last step is review the algorithm. Have peers or expert review the pseudocode or design. Gather feedback on the clarity, efficiency, and feasibility of the algorithm. Consider alternative approaches suggested during the review. Make necessary adjustment to the algorithm design based on the feedback. This is the final step is to review the algorithm. First, we need to work through the algorithm step by step to determine whether or not it solved the original problem. Once we are satisfied that the algorithm does provide a solution for the problem, we start looking for the things. That is, there is a following questions arise. That is, does this algorithm solve a very specific problem? Can this algorithm is can be simplified? There are questions will be arise. So these five are the steps in developing the algorithm. Next one is method of specifying algorithm. There are only two methods of specifying an algorithm. First one is pseudocode and second one is flowchart. We will discuss what is pseudocode. Pseudocode write a structured high-level description that resembles programming code but does not use specific syntax of any programming language. Balances readability and precision, that is easy to translate into actual code. That is the main advantage of the pseudocode. It requires familiarity with the programming concept. That is the advantage. Disadvantage, that is, it is a method of describing computer algorithms using a combination of natural languages and programming languages. It is essentially an important step towards the development of the actual code. It allows programmer to formulate their thought on the organization and sequence of a computer algorithm without the need for actually following the exact coding syntax. Pseudocode is frequently used. There are no set of rules for its exact implementation. There is only few rules. That is, the usual Fortran symbol are used for the arithmetic operation. Symbolic names are used to indicate the quantities being processed. Certain Fortran keyword used print, write, read. These three rules are used in the pseudocode. This is the example of a pseudocode. This is algorithm grade, that's the input, a numeric score as output, a letter grade. The second one is flowchart. Use diagrams to represent the sequence of steps and decisions in the algorithm. Visual representations can make understanding the flow of the algorithm design can become complex for large algorithm, not easily convertible to the code. It is a diagrammatic representation of an algorithm. It uses simple geometric symbols and arrows to define relationship. Flowchart symbols are linked together with the arrows showing the process flow direction. Document flowchart, there are so many type of flowchart. I will tell you them a few one, that is document flowchart, data flowchart, and the system flowchart and the program flowchart. This is the example of a flowchart. You see difference between an algorithm and the flowchart. We already know that what is an algorithm and what is a flowchart. Last one is decision prior to designing an algorithm. Based on the capabilities of the device, processing power, SSD computational power available, that is CPU speed, number of core. This influences the complexity of the algorithm you can afford to run. Memory constraint determine the availability of memory and storage. Some algorithms require more memory than others, and this may limit your choices. Parallelism evaluate whether the device supports parallel processing. If so, you can design algorithms that leverage multi-threading or distributed computing. Power consumption. For battery-powered devices, consider the power efficiency of algorithm, especially for mobile and embedded systems. Specialized hardware. Check for the presence of GPU, TPU, or other specialized hardware that can accelerate certain computation for deep learning for graphics processing. Second one is based on the nature of solution. Deterministic versus non-deterministic. Determine if the problem requires a deterministic solution, that is, always produces the same output for the same input, or if non-deterministic or probabilistic solution are acceptable. Exact versus approximate. Decide whether an exact solution is necessary or if an approximate solution will suffice, which can significantly reduce computational requirement. Real-time requirement. Assess if the solution need to be real-time, which impact the algorithm time complexity and responsiveness. Scalability. Consider how the solution will scale with increased input size and whether the algorithm need to handle large-scale data efficiently. Robustness and fault tolerance. Ensure the algorithm can handle error gracefully and robust and it must be robust against invalid input or unexpected condition. Last one is based on the most suitable data structure. Data structure suitability. Identify data structure that best fit the nature of the data and operation required. Different data structure optimize different operation, that is search, insert, delete. Complexity of operation. Evaluate the time and space complexity of various operation on different data structure. Choose the one that offers the best trade-off your specific use case. Dynamic versus static data. Decide if the data structure need to handle dynamic data. Access patterns. Consider how the data will be accessed, sequentially, randomly, or frequently accessed items. Memory usage. Choose data structure that use memory efficiently, especially important in memory constrained environment. We discuss algorithm design, the important concepts of algorithm design and the main steps in developing algorithm, the method of specifying algorithms and the decision prior to designing an algorithm, the three concepts. Hope all of you understand. Thank you.